Hello friends, I am Snapak Bhattacharya and today we will learn about sets, the basic concept about sets and its representation, how to represent sets. So now we will understand what is set. Okay, so set was developed by German mathematician George Cantor. So we often talk about some collection of particular kinds, like a pack of cards we play with, or a cricket team or a football team. These are examples of some collections we talk about every day. So in mathematics we also talk about some collections. So here are some examples of some collections, and we will discuss about this. First one is odd natural number less than 10. Okay, what are the odd natural numbers which are less than 10? We know that these are 1, 3, 5, 7 and 9. Natural numbers are starting from 1, and natural numbers actually the integers, but it starts from 1, not from 0. All positive integers are natural numbers except 0. The rivers of India, it's a collection, and the vowels of English alphabets, if we say these are A, E, I, O, U, these are the vowels of English alphabet, and various kind of triangles. These are also example of some collections, and the prime factors of 2, 30, these are 2, 3, 5 and 7, I suppose, and these are also some collection. The solution of the equation x square minus 5x plus 6. So if we solve it, is like x square minus 2x minus 3x plus 6, like that. So we get x minus 2 into x minus 3 equal to 0. That means it says x equal to either 2 or 3. It's also a collection. The solution of the equation, quadratic equation, is also a collection. So what's special about this collection? The speciality about this collection is these collections are well defined. So what is well defined? Well defined means we can, if we take an element and we can particularly tell that this will belongs to a particular collection or not. Okay, any element we pick, we can say that this will belong to this collection or not. So like this one, the rivers of India. Okay, if we take this collection, we can name any river, like Nile, that's the longest river in the world, Nile, and it does not belong to this collection. Why? Because Nile is in Africa. Okay, Nile river is actually belongs to Africa, so it will not present in this collection. This collection is well defined because it particularly says that rivers of India. Okay, so rivers of India means only the rivers that are in India will belong to this collection. So Ganga will be in this collection. Okay, so we are talking about well defined collections. So what are not well defined collection? Let's talk about that. Okay, example that is not well defined. Let's talk about this. So if we take a set, a collection, what is, let's say top 5 best actors in the world. So if we say top 5 best actors in the world. So is this a well defined collection? So we haven't decided the criteria for best actors on which we will tell these are the best actors. We haven't decided any criteria, like we can say that best actors according to the award of Academy Awards of USA or Golden Globe Awards or USA, you have to, or BAFTA, the British Academy Awards, or number of movies they have performed, or the screen presence time, like that. We haven't decided the criteria, so you can tell the 5 best actors in the world in a particular manner, because the criteria for different persons will be different. So how we will deal with that? As this is not well defined, it will be not a set. So set actually a well defined collection of elements. Okay, so we got the definition. Okay, what is the definition? The set, a set is a well defined collection of objects. We took the collection like the rivers of India, and in that collection, that every member should be well defined. The collection should be well defined, that we can decide that any member is belonging to the collection or not. Okay, now so here the terms objects, elements and members we use in the sets are same. Okay, now there is no difference between objects, members and elements. And actually we usually, not every time, we usually capital letters for sets. We use capital letters for sets, where small letters we use for elements, members, whatever, or you can say the objects we use, that's A, B, C. We will be using to represent sets, and for small letters we will be using for elements. So we in the mathematics use some collection of sets. We will be denoting them by the writings, by the letters, actually by the letters in the board. So we will talk about right now about that. Like n, it's actually the set of all natural numbers, actually this represents set of all natural numbers. So what are natural numbers? Natural numbers, actually I said all the integers except 0. Okay, all the positive integers like 1, 2, 3, 4, 5, 6. These are the set of natural numbers. And what is Z? Z are set of all integers. You don't have to remember all of this. When you study mathematics, you will remember all of this by practicing. You don't have to remember this, just for knowledge. You can take this as a knowledge, but you don't have to remember it. You will be able to remember it when you go through further mathematics. So Z will represent the set of all integers. What are the integers? You can take from minus infinity and take the only integers, like I said -3, -2, -1, 0, then 1, 2, 3. So these are all the integers from minus infinity to infinity. So you can see this, the set of all integers. And what is this? This is the set of all rational numbers. So these are the set of rational numbers. What are rational numbers? Rational numbers are those numbers which can be represented as P by Q, where P and Q are integers and actually Q not equal to 0. This is the condition for a rational number. Rational number should be represented by the form P by Q, where P or Q are integers and Q not equal to 0. R is the set of all real numbers. Set of all real numbers. What are real numbers? Real numbers means all the numbers which are rational and rational. Whether you can say root 2 is a irrational number. You cannot represent this one as this form. So these are irrational numbers. So rational and irrational, all numbers are real numbers. And there are imaginary numbers too, because if you will study further, when you will study further, you will learn that if x square equal to minus 1, then x is equal to root over of plus minus. You can use the term root over of minus 1. This is represented at I, and x minus iy is the form of a complex number. Okay, so these are imaginary numbers. So these doesn't belong to real numbers. So set of all real numbers is represented by R. Z plus is simple. This is set of all positive integers. This is set of all positive. You can say like this, positive integers. And these are the similar. This is a set of all positive rational numbers and set of all positive real numbers. So this is how we will represent few terms, few actually sets of mathematics we will use in further study. So now let's talk about some notations. Okay, so if any element belongs to a set, then we say that, suppose we take a set A, which is all natural numbers less than 5. Okay, all natural numbers less than 5. So it's 2, it's 3, it's 4. Okay, these are set of all natural numbers less than 5. Okay, so from here we can say that here any element, suppose the element 4, we say 4 belongs to set A. Okay, how we will represent it in mathematical form? We like 4 belongs to A. So this epsilon, this is epsilon of Greek alphabet, which denotes belongs to word. It represents that belongs to. So element 4 is an element of the set A, and we say 4 belongs to A. Suppose a element which is not in the set A. So if we take a element 7, suppose, so 7 isn't in the set A, so we say that 7 does not belong to set A. So we say that 7 does not belong to set A. How we will represent it mathematically? 7, then epsilon cut, then A. So 7 does not belongs to set A. This is how we will represent sets. Okay, so now there is two forms, roster form and tabular form. Tabular form or roster form, and there is a set builder form. We will talk about that. Okay, now, so what are the forms? Roster form or set tabular form. So tabular form and roster form are same thing. So tabular form and roster form are same thing. Okay, so what is the another form? Another form is set builder form. Set builder builder form. So set builder form. So these are the types where how you can represent sets. Okay, so we will be talking about that. Suppose we are taking a set that is suppose a set A. Okay, A suppose, maybe we can take V. Okay, now V for vowels. So what we will see, we will write that X is a vowel of English alphabet. What I have written, that X, V is a set, we are writing in set builder form. X colon, we have to put a colon. X is a vowel of English alphabet. In roster form or tabular form, we have to write just like that, A, E, I, O, U. Okay, this is set builder form, this is roster form. Very easy. We can take another example, like if we take a set A, let's talk about A. What we can write, okay, X colon, X is a natural number, and it should be in one line, it would be better, so I am using that. Suppose it's A, set A, it's actually set builder form. Okay, X colon, X is a natural number and 3 less than X less than 10. Okay, so this is a set builder form. Okay, this is a set builder form, and we can write in tabular form. How we can write in tabular form? So A set will be like this. This is actually V set. Okay, na? So A set will be natural numbers. That means we will use 4, 5, 6, 7, 8, 9. This is a natural numbers, all natural numbers between 3 and 10, and 3 and 10 cannot be used because these are used less than, not less than equal to symbol. If this symbol were used, then we can use 3 and 10 included in this set, but as only less than used, so we will take from 4 to 9. Okay, this is set builder form and this is tabular form. Let's take an infinite set. Okay, now let's take some infinite set. The set have no ending like that, so it will be easy to understand. Finally, before that we let's assume the word element. Okay, this is a word element. Okay, we will make a set of by taking the elements of the word, members of the word element. Okay, now alphabets. So how we will represent that in tabular form? Actually, E, suppose A is the set containing all the alphabets in the word element. Okay, now so E, then L, then there is a E, but we will not write E, we will write M. We are skipping E, and we are then again skipping E, and we are writing N, then we are writing T. So there are 2 E's, but we skipped that. Why we skipped E? Because only once an element will be an element or member will be in the set. Okay, now the repetition isn't naturally occurring. Okay, usually we don't use repetitions. So like that, if we use the word school, suppose SCHOOL, school. So if B is the set representing all the alphabets of the word school, so what will be the set? SCHOOL. The O will not repeat more than one because these are distinct elements. We have to only take the distinct elements we don't have to repeat these letters. Repetition don't usually taken in consideration. Another thing, if B is a set, this we can represent like this: C, L, O, S, C, okay, and H. So we can rearrange the elements of the set. We can, this will represent same, this is the B set, these are same, these all I have written SCH double L, sorry, I have repeated C. So if we write like this, there is no difference between these two sets. Why? You can rearrange the elements of the set, okay. So there is no problem in rearranging the elements, and you can also you can also skip the repeated elements, okay. This is how we will represent sets. So we are talking about some infinite sets, okay. What's some infinite sets, how we will represent that? Suppose A is a set, how we will be writing that? X is an odd natural number. What is this? Is set builder form. This is a set builder form. And how we will write this in tabular form or roster form? Tabular form or roster form, how we will write this? We will write A. What are the odd natural numbers? 1, 3, 5, 7, and these are going on. This is how we will represent the odd natural numbers. This is an infinite set. So this is how we will represent the odd natural numbers. This is set builder form, this is tabular form. I hope you will understand how to build a set like this. By doing those two problems, we are ending this video, okay now. So these are the two sets given in tabular form or roster form. These are given in tabular form or roster form. So we have to convert these sets in set builder form. Set builder, UIL DR, builder form. So how we will represent this? Simple. A is a set, X is an element of the set A, X is a square of natural number. How we will do supposed to know that? Because look at the set, it's 1, it's 4 means 2 square, it's 9, it means 3 square, it 16, that means it's 4 square, 5 square. This is if you take the natural number set, that is 1, 2, 3, 4, 5, and if you square every element of the natural number set, then you will get this set. What is the set? 1, you see, 2 square, 3 square, 4 square, 5 square. So this is how we will write in set builder form, or more mathematically we can write A is equal to X colon X is equal to n square, where n belongs to n. N means set of all natural numbers, that is n, okay now. So n belongs to n, these elements belongs to n, and x's value is n square. So if you put any value of natural number in n, you will get, suppose you put 1 belongs to natural number, then it will be 1 square, 2, that will be 2 square, means 4, that element is present in there. And if you take 3, you will get 9, if you take 4, you will get 16, and so on. So let's take a finite example. So it's also in tabular form, we have to represent that in a set builder form, okay. So how we will represent that? We will take the set A, where Ax is an element of the set A, and x is equal to, you say, 9 n plus 1. you can see that this 1, there is 2, this is 2 by 3, that is 2 plus 1 is equal to 3, 3 by 4, 3 plus 1 is equal to 4, 4 by 5, that is 4 plus 1, 4. This is how we represent the set. And where we can say that where n belongs to n, and there is something else, that is there is a restriction to the value of n, that is 1. You can take 1, that is n, so it starts from 1 and ended with 6. Okay, how we will write that? Okay, so this is n by n plus 1. We understand that because 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, 3 plus 1, 4. This is how we will represent that. How we will get this what is interval? You start with 1, n value, n's first value is 1, so we have taken less than equal to yes, n value is greater than equal to 1, including 1 and the value above 1, and n is natural number, there is no problem. Then the number after that will be 2, then the number after that will be 3, then the number after that will be 4, 5, and at last it will be 6. Okay, we can represent this is not the final, we can change it like there will be no difference. Why? We remove the less than equal to sign, but it belongs to natural number, so less than 7 there will be no 6.5 and 6.6, there will be only one element, that is 6. If we write this thing, there will be no problem. Okay, because less than 7 only one natural number, actually less than 7 there are lots of natural numbers up to 6, but there is no numbers between 6 and 7 that will attain the value of n, because it belongs to natural numbers. Less than 7, that means only 6, so there is no problem. You can write this or this, there is no big deal. Okay, so let's end here. If you want to see the exercise 1.1 of CBSE NCERT class 11, exercise 1.1 of this set chapter, solution of this, I will put a link in the description. You can have a look. It's in Hindi. If you want this exercise solution in English, you can comment down below. I will make a video on the exercise solution in English. It's already in Hindi. I will put the link in the description if you want to see that solution of the exercise in Hindi. Okay, bye. Have a good day.